Okay, hi everyone. I just wanted to quickly go over the last page of lecture today since we didn't have too much time to go over this in class. But we got to about step 3 in this problem. Right here, step 3. So it says to compute the t statistic. Now our test statistic is t instead of z because remember all 3 of the conditions were met. And you'll notice the formula for t is actually exactly the same as the formula for z. It's still observed minus expected divided by standard error. The only thing that's different is our standard error has this adjustment. We have to use the SD plus when calculating our standard error instead of the SD because we have a small sample size. We need to make that adjustment. So I did that up here. I calculated the SD plus. We got 12.39. And then when I used my standard error formula, SD over square root of n, I did the SD plus as an estimate of the SD, and n was 16. You'll notice right here, there's another formula. This, I prefer this one right here because it's the same as always, right? SD over root n. We're just making that adjustment with the SD plus. This does simplify to this formula over here, but that's kind of a completely different formula than the ones we've been doing. So either one that you want to do, if you do the SD, which was 12 in this problem, divided by square root of 15 and minus 1, you should get the same exact thing, 3.0975. So that's what that is. I wanted to make sure to explain that. Then when I plug in my standard error calculated using the SD plus, we can call it SE plus if we want. When I plug it in, I get t is equal to 1.61. So that's my test statistic. I need to find my p-value. It says step 4, compute p using the student's curve and the t-table. So instead of using the normal curve, I want to use the t-curve, and there's 15 degrees of freedom, just like we talked about the other day. Degrees of freedom is just n minus 1. The t-curves change depending on the sample size. So if our degrees of freedom is 15 and our t-statistic is 1.61, this is how we would use the t-table. So I'm over here on the other side. Here's the t-table. It's pretty easy to use. I'm going to go down. I have 15 degrees of freedom, right? So I'm going to go down to that row. And then I'm looking for these, all of these numbers are t-statistics. So I'm looking for mine. I'm looking for the 1.61. So I'm going to go over. I probably won't find exactly my number, but I do know that 1.61 is in between 1.34 and 1.75. So that means up here, these percentages, these are the p-values. So that means if I look up, 1.34 has a p-value of 10%, 1.75 has a p-value of 5%, so I know mine is somewhere in between 5 and 10%. So that's why I actually said on this other page, the p-value is between 5 and 10%. I don't know exactly what it is, but all we need to know for my conclusion is it less than 5? So if your t is anywhere to the left of the p-value of 5%, that's when you would reject the null. All right, so I am not in 1.61, right here, 1.61 is not in the rejection region. So I would say as my conclusion, my p is not less than 5%. It's not less than 5%, so we do not reject the null. Okay, so I'm not rejecting. The null says the difference is just due to chance. I'm not rejecting that. There's evidence that the difference is just due to chance. So hopefully that makes sense to you guys. Have a good weekend. I'll see you on Monday.